Okay, dear students, today I'm going to be discussing hyperconjugation with you. It's a very important organic phenomena, and you will find this phenomena when we will be talking about the stability of various molecules or the stability of various reaction intermediates. So this has a big role to play in the stability of various species in organic chemistry. So hyperconjugation is also known as no-bond resonance and also known as Baker-Nathan effect. So if it is asked as as the name of Baker-Nathan effect or as no-bond resonance, don't get confused. These are the other names for hyperconjugation. So hyperconjugation is basically displacement of sigma electrons to unfilled orbitals. You know, in organic chemistry, we have two types of electrons, sigma electrons and pi electrons. Are the saturated bonds or single bonds are formed from sigma electrons, as those are sigma bonds. So multiple bonds, they consist of pi electrons, as they are known as pi bonds. And these two types of electrons, they differ from each other in terms of the type of overlap that is undertaken to form those bonds. So, you know, in case of sigma bond, there is axial overlap, proper overlap, and whereas in case of pi electrons, yeah, or pi bonds, there is lateral or sidewise overlap. So hyperconjugation is a permanent effect. That means as long as a molecule is there or as long as a intermediate or its structure is there, this phenomena will always be there. So what is hyperconjugation? Just try to understand what is hyperconjugation. It is a very beautiful phenomena. Suppose this is a molecule in which this particular carbon, it's alkyl group CH3, and it is attached to a this particular carbocation. It can be any carbocation. I have just taken it to be a ethyl carbocation. So here it is a carbocation. There is it's carbon containing positive charge, and here it is a carbon which is having which is attached to three hydrogen groups. So what happens that this particular carbon, if I speak in terms of orbital picture of this particular carbon, this carbon has to be sp2 hybridized. So it's planar, its structure is planar. It has three bonds with a bond angle of 120 degree, right? So what happens, it has an unhybridized p orbital perpendicular to this plane. This is how carbocations look. Now adjacent to this carbocation is a carbon which is having three sigma bonds. It is sigma bonded to three other atoms or groups, or in this particular case, it is bonded to three hydrogen atoms. So what happens that uh, these sigma electrons, here we have two electrons, these sigma electrons, they get mobilized from here, from this bond to this unhybridized p orbital. They form a bond, a partial overlap. They do a partial overlap with this particular orbital, this unhybridized p orbital adjacent. Okay, so what happens that the structure which was earlier something like this, now we have changed structure. It will be a new intermediate or a new form will be generated, which will look something like this. Here is a H, here is a H, there is a carbon, it is having two substituents. Now what happens that it has positive charge and a unhybridized p orbital. So what happens that sigma electrons from this particular bond, they get migrated towards this unhybridized p orbital. So they form a sort of a double bond, not complete double bond, but electrons, they get migrated towards here, and in turn our hydrogen is carrying now the positive charge. So this a new form is generated. This is a hyperconjugative form. This is known as hyperconjugative form. So what has this form done? This form has stabilized this carbocation. It has taken away the positive charge from this carbocation and it has provided it with the electrons. So where did these electrons come from? These electrons, they came from this sigma bond which was all present first there, this particular bond. So now it is not there because these electrons, they got migrated towards this particular carbon atom, and a partial overlap took place between these sigma electrons and this p bond. So this particular hydrogen now has no bond between, there is no particular bond between this carbon and hydrogen. That is why it is known as no bond resonance, because it's different hyperconjugative forms. They have what? No bond between two atoms. So now what happens after some time? This particular hydrogen, which will come back to this particular carbon. So now what will happen? This particular hydrogen will go away, and its sigma electrons will be used in generating double bond. And after some time, this hydrogen will come. So in a way, how many forms we will be creating? 3 hyperconjugative forms. How? I would like to show you here. So one form is where this hydrogen goes away, and then we have another form in which we have this carbocation, something like this. Now this particular hydrogen is away, and these two hydrogens are attached to it, and in another hyperconjugative form, these two hydrogens will be intact and this hydrogen will be going away. So that means more are the number of hydrogens attached to this particular carbon, more is the number of hyperconjugative forms. So this is one hyperconjugative form, this is second, and this is third. So all these hyperconjugative forms, what do? They take away the electron deficiency, or we can say the positive charge from this particular carbocationic carbon. So they stabilize this particular carbon. So this is known as hyperconjugations. Hyperconjugation, what is hyperconjugation? बेटा, this is a very simple phenomena. Just try to understand. इसमें क्या होता है कि जो आपके सिग्मा इलेक्ट्रॉन्स होते हैं किसी भी बॉन्ड में, जैसे इस बॉन्ड के जो सिग्मा इलेक्ट्रॉन्स हैं, इसके साथ में ही एक ऐसा कार्बन है जिसके पास ऐसा ऑर्बिटल है which is empty, which is unhybridized, it is vacant orbital. So what these electrons, they get migrated or they get displaced towards this. This overlap is not a proper overlap, no proper double bond formation nahi hai, but just electrons get drawn towards this unhybridized orbital. So what happens that a multiple bond type structure is created here, and this particular hydrogen, it goes away, and what do we see? We see that our molecule, our structure is stabilized. So hyperconjugation is a phenomena which you will see in various organic structures. Hyperconjugation की बहुत ज़्यादा applications हैं आपके जो organic chemistry है, इसमें time and again you will be introduced to this concept hyperconjugation. So it is just displacement of sigma electrons towards unhybridized. तो ये जरूरी नहीं है जो मैंने आपको दिखाया, it can be carbocation, it can be anything. It can be a double bond also. For example, this particular double bond. इसके साथ में we have a alkyl group. So what will happen that इसके पास भी unhybridized p orbital है, right? So what happened that what will happen that these particular electrons, they will migrate towards this particular carbon. So and sorry, this particular orbital, and there will be a double bond like structure. So these electrons, they will migrate here, and we will get a species like this, H positive, double bond type structure, C negative. Okay, so this is what happens. Earlier it's this particular carbon had double bond with this, it was having overlap with this. So what happens that in this, its electrons, they come here, they form a double bond with this, overlap with these orbitals. So what happens now? There is a overlap here, and its electrons, they get localized here, and we get a carbonyl. because positive charge is made by this particular hydrogen. So this is hyperconjugation. It is not only in carbocations, but it is in all those cases where a alkyl group is present adjacent to a unfilled orbital. Alkyl group adjacent to a unfilled orbital. So if we talk about applications of hyperconjugation, you will find many applications. The study material I have already provided to you. You will go through it once again while you are listening to this particular lecture. So first and foremost application of hyperconjugation is stability of carbocations. You know, I have already discussed it with you that if there is a carbocation, suppose this is a carbocation, CH3 positive CH2, this is a primary carbocation, है ना, ये एक प्राइमरी कार्बोकेटाइन है. तो इस पर्टिकुलर कार्बन के पास कितने हाइड्रोजन है? 3 हाइड्रोजन. सो ये 3 हाइपर कंजुगेटिव फॉर्म्स जनरेट कर सकता है. दैट मींस देयर आर 3 टाइम्स इट कैन टेक अवे दिस पॉजिटिव चार्ज. सो इट विल बी स्टेबलाइजिंग दिस कार्बोकेटाइन. उसके मुकाबले में हमारे पास अगर एक कार्बोकेटाइन है, सेकेंडरी कार्बोकेटाइन, इसके एडजेसेंट कार्बन पे 6 हाइड्रोजन्स हैं. दैट मींस 6 टाइम इट कैन टेक अवे इट्स पॉजिटिव चार्ज 6 टाइम्स. सो it will be stabilized 3 times more than primary carbocation. And if we talk about tertiary carbocation, it has 9 carbon hydrogens attached to adjacent carbon. So that means 9 times its positive charge can be dissipated. So this is most stable form. That is why primary carbocation is less stable than secondary carbocation, and secondary carbocation is less stable than tertiary carbocation. This can be explained on the basis of hyperconjugation. Okay, hyperconjugation is the phenomena which explains this particular stability order that we have observed, and the same has been observed in case of free radicals also. क्योंकि फ्री रेडिकल्स के केस में भी हमारे पास यही होता है, वहां पर हमारे पास पॉजिटिव चार्ज की जगह क्या होता है? फ्री रेडिकल. जो फ्री रेडिकल होता है तो उसमें भी हमारे पास इसी तरीके से हाइड्रोजन एक इलेक्ट्रॉन लेके साइड पे हो जाता है, और हमारे पास सिंगल इलेक्ट्रॉन इसके सिंगल इलेक्ट्रॉन के साथ मिलके एक डबल बॉन्ड बना लेता है. उसमें भी हमारे पास हाइपर कंजुगेशन जो है वो रिएक्शन इंटरमीडिएट को स्टेबलाइज कर देती है. So stability of carbocations and free radicals can be completely explained with the help of hyperconjugation. देखिए दूसरा हमारे पास ये है कि आपके पास जो एल्कीन्स हैं, कुछ एल्कीन्स की स्टेबिलिटी जो है वो ज्यादा होती है, कुछ एल्कीन्स की स्टेबिलिटी जो है हमारे पास बाकी एल्कीन से कम होती है. So how can we explain that phenomena? That can again be explained on the basis of this. जैसे कि हमारे पास ये एक एल्कीन है, सॉरी, सो इस एल्कीन में आपके पास 3 हाइड्रोजन्स इसके एडजेसेंट है, जो क्या कर सकते हैं कि हाइपर कंजुगेशन के थ्रू इसको स्टेबलाइज कर सकते हैं. देखिए पहले ये हाइड्रोजन चला जाएगा और यहाँ पर डबल बॉन्ड बनेगी और यहाँ पर नेगेटिव चार्ज आ जाएगा, फिर ये हाइड्रोजन आ जाएगा, फिर ये हाइड्रोजन आ जाएगा. दैट मीन्स देयर आर 3 चांसेस. उसके कंपैरिजन में अगर आपके पास ये एल्कीन है, इस एल्कीन में जो ये एडजेसेंट कार्बन है इसके पास ऐसा हाइड्रोजन नहीं है, which what will do that it will stabilize this particular. So that means this particular structure will be more stable. Those species, those alkenes are more stabilized जिसमें जितनी ज्यादा hyperconjugative forms बन जाती हैं. That means इसमें देखिए हमारे पास कितने अल्फा कार्बन पे कार्बन से हाइड्रोजन से 3 पे, इसके अल्फा कार्बन पे यानी कार्बन एडजेसेंट टू डबल बॉन्ड देयर इज नो हाइड्रोजन, नो कार्बन हाइड्रोजन बॉन्ड है, उसकी वजह से इसमें कोई हाइपर कंजुगेटिव फॉर्म जो है वो पॉसिबल नहीं है. सो दिस विल बी मोर स्टेबल देन दिस. सो बेटा दिस इसी तरीके से आप बहुत ज्यादा जो है डिफरेंट स्ट्रक्चर्स को ऑब्जर्व कर सकते हैं. आपकी बुक में बहुत ज्यादा एग्जांपल्स दी गई हैं. जस्ट कीप these the things I told you, keep these things in mind and just try to go through the study material once more, and I'm sure most of your doubts will be cleared. So अगर still you have any doubt, you can always ask.